Hello everyone, and welcome to another Edinburgh Napier Built Environment Society webinar 2020-21 event. I hope you're all well, as unfortunately we are still in the middle of a pandemic. The Built Environment team are still working on these webinars as they're gaining much more popularity. These webinars are also providing our future engineers an opportunity to see what the future holds for them. Just a small introduction about myself. My name is Stephen Davies, third year civil engineer and the current president of the Society. Today we are joined with Ben McGarity, the Vice President and former President of the Society, and Paul Chambers, a part of the events team and former Vice President. I will now pass you on to Ben and Paul for their introduction and bring in our guests for today. Thank you very much for joining and enjoy.
All right. My name is Ben McGarity. I'm a fourth year student at Napier. We've been continuing this event since last year, and I have now brought Stefan on to sort of take the rein in this event and sort of host this for today. I'm a fourth year student, as you know. I'm studying civil engineering, and yeah, I mean that's pretty much me down to a T. And I'll hand yourself over to Paul, and we'll go from there. Today we're joined by Ken Brown from Balfour Beatty, and we're going to get a bit of insight to his career path so far, and a little bit of insight into the A9 dueling. Over to you, Paul.
Thanks, Ben. I'm Paul Chambers. I'm a fourth year civil eng student at Edinburgh Napier, and I'll be around at the end of the call if anybody's got any questions. We'll have a Q&A, so if anyone's on any of the live feeds, post a comment down below and we'll get them through and I'll read them out at the end and ask Ken anything you've got. With no further ado, I'll pass on to you, Ken.
Thanks very much, guys, and good afternoon to you all. So those who, I'm going to turn my volume down so I can hear you. Okay, that's maybe a bit better there. I've got a lot of feedback coming back through that. So a number of years ago, probably about 36, 37 years ago, I qualified there at Napier, and it was in the time there it was HND, a sandwich course that we completed, 6 months in study and 6 months out in industry. First summer out was working for a contractor in North Berwick, and we put a new lighthouse on the island of Swona, which is the second one up in the Orkney group. So the first time I'd flown off a helicopter and all sorts. So that lasted a few weeks, finished that, and then I worked with Gleason's, and we built the new sewage treatment works at Linlithgow. Following year back to college at the time. Following summer, worked for Balfour Beatty down at Sellafield, and the following year I then started with Balfour Beatty. The first contract was at the Musselburgh bypass, part of the A1, and that was a million years ago by the sounds of it. But it's very fresh to me, and every time I go over it, I take a lot of pride in my part in the structures I built there. So that was, what, 35 years ago. The contracts I have worked on and positions. So I started off as a site engineer, then on a section engineer, sub-agent, agent, project manager, and dabbled a bit in other areas, planning, marketing, estimating, and corporate social responsibility, which all forms part of a wide range of talents that we actually need as engineers. Contracts that I've worked on, so I touched on Musselburgh bypass. Following that, I went back down to Sellafield in Cumbria, and that was the CAGR unit and Thorpe. From there, we ended on different areas around Scotland. So Dunblane bypass, down in Newcastle, Western bypass, did a sewage treatment plant down in Hordern, the primary works and the secondary works. The water treatment plant in Inverness, refurbished the Keswick Bridge, a pier in Stornoway in 1996. Aberdeen, Third Dawn Crossing. I won't touch on the E9, I'll cover that one in a minute there. Irvine Paper Mill, Kilmarnock Bypass, just to name a few. So a lot of different types of contracts, roads, civil engineering, quite complex at times, and challenging temporary works, especially when you come to structures and having crane lifts, which you're needing a 1,000-ton crane with super ballast to lift in. Very much different. While all that's been going on, I've kept in touch with the university, taken many a student on a site visit. These are having to be virtual, which is effectively what we're doing today. Created summer placements. If any of the fifth-year MEng are on this, you'll aware I'm mentoring a group, a third of the class for IB2, I think it is, or IBM2, to take it through to April. And that gives me an opportunity to meet students and sometimes suggest that they should apply to Balfour Beatty to work. So instead of it being a half-hour interview, it tends to be 12 weeks, quite intense. And there has been quite a number of students that have come this path and are now working with Balfour Beatty and are still working with Balfour Beatty. I'm sure you all have plenty of questions to ask me, but I think we'll just start the video now, if that's all right with you guys. And I'll take you through the A9. So hopefully that should start running. Yeah, that's great. It's running on my screen now. I'm not hearing any sound in the background, but I'll just take you through. So Scottish Government wanted to dual between Perth and Inverness. So there's several sections that are single carriageway and some that need to be dualled. So the section that we're looking at is just north of Perth. So this is from Perth on the left-hand side there up to Lunkerty. And there's a couple of kilometres to start with a dual, and then we pick this up and we basically do a parallel one online. So it's a dualling. Okay, and there's several structures that we have to do. I'm just going to pause this here because there's quite a bit to talk about. So from a design point, this is a design and construct. So Atkins are working with us to design where we construct. Jacobs are the client's representative on site, and the client being Transport Scotland. Very onerous for the consultation, so we've got a lot to comply with. A lot of temporary works, a lot of utility diversions required as well, 55 of these, and everything has got to be signed off, whether it's approval from landowners or from the designers. The contract itself, about 60 million, 9.5 kilometres of main carriageway, there's 3 kilometres of side roads. A lot of this because of the agricultural element. This segregated junction here and up at Bank Foot, effectively a parallel widening. Earthworks, so in this 9.5 k, we've got 700,000 cubic metres of material to excavate, of which 500,000 literally goes into this interchange here. A mixture of pavement design with the CBGM, which is basically a lean mix concrete base and then a flexible pavement on top. And on the structure side, under bridges, there's 3 4-over bridges and a retaining wall up at this section here, which I'll come on to later. So that just gives you a snapshot from road. Either bypasses you can have are totally greenfield, whereas this one is a mixture of effectively greenfield and reconstituting the existing one. So on the right there was the existing carriageway. We've built the new one on the left, and then it swaps over further up. 2 temporary areas for storing of topsoil. So that's the first thing to come off and the last thing to go back on. Culvert here, which would extend from here all the way out. Now, working in streams, a massive restriction from SEPA, what you can't do, because wildlife. So it took us about 12 months, but we managed to get footage of this otter there in a kit. We also picked up a beaver. This is probably the only decent footage we have of the local beaver, because it's normally just a photograph or a thing of tail or bushes moving. So to get the footage is very, very, very rare. So that culvert was formed with precast concrete panels and lifted in, occupying half the river at a time. This minimised the amount of live or wet concrete going into the river. To get past this river, we actually installed an army-type Bailey Bridge. We launched this in place. This then gave us access to earthworks and negated the need for transporting on the road. We could actually transport on our haul road. Now this is speeded up, and if you blink, you'll miss quite a lot here. So it's the excavation works at the culvert here, getting ready. Then we bring in the crane. This lifts in the precast units, swap over to do the other side. And once they're in, we can then backfill over the culvert, and that then starts joining up the road there. So bring the material up to formation, done with the capping, remove any soft spots from the testing, come through with effectively the concrete road and then the surfacing. Following that, as you'll see coming through there, is in the verge works, drainage topping up, topsoiling coming through there. You see the winter coming in, and then getting ready to put the traffic on it. But before we put the traffic on it, the adjacent bridge, which you'll see in a minute, took the beams in, and then so this bridge here is Palandi Bridge. It's called. It's mainly for farm traffic and local traffic to get across, whereas previously they went down that track and nipped across. Large suds pond there, sustainable urban drainage system. So this bridge, because many visits to the site we've had, so we split this down into abutments, piers, precast beams, and then on the bridge deck, onto copes, backfill, extension wing walls, out of the parapets, and then you got your impact barrier on the top. So how does that actually look like in real life? You'll see the sheet piles on the other side. That's because the excavation for the pier is that close to the road. So piers on this side. Now we tried to ensure that we had as much replication, so the formwork could be used again and again. So that, as you'll see, the standard style of the piers are the abutments. And then when we're ready for taking in the beams lands directly on top of the structure. There's no bearings as such. It's integral. Viewing platform across on the left-hand side there for people to come and see. Everybody's very interested when you bring in a 800-ton crane to lift these beams. You see them doing a couple of trial test loads there, getting the strops the right length so it comes down and then secured into place. So this was a nighttime possession, closure of the A9. Diversions 30 miles either side. So a lot of advanced planning to do this. You can't just do this on an ad hoc basis. And once you're committed to that date, that's what you've got to go for. So some beams are longer than the others. Once we got the precast beams on, we then lifted on the cantilever sections, trying to focus on the road possession and then drop back onto the bits that are not a road possession. So once they're in place with them, the plastic GRP panels, steel fix the deck, and then we can cast the deck. And then cast the diaphragms, which are at the abutments and over the piers. As soon as it allows it, we can get the topsoil onto the verges, onto the embankments, and get the planting. Thousands and thousands of new trees getting planted. Part of that is to negate the trees that had to come down for the corridor of the works. See the junction there? That effect will get done away with at the end of the day, and this road here would be the access. So it minimising traffic coming onto the carriageway and increases the safety of the road, whether that's from tourism, tractors, or anybody else coming on. Now in this area here, like I said, 500,000 cubic material was imported, and part of the works with Atkins was using 3D design and modelling. I'm not sure how many of you are working with a consultant are going to be. Yeah, the colours are a bit wild, but they help highlight and detail different elements. Now this can be used with initial 3D modelling, then taken onto the 3D design. Now the whole point of this is though that we can highlight potential clashes, whether it's a base of a sign hitting a drainage, whether it's ducting going up, whether it's an existing culvert or lade which you require deep drainage. So you'll see in the background here, this line here. So that's a culvert we'd install before the earthworks. And then show where the cycle paths are going, visibility displays. So depending, this is obviously a fly through, but you can position yourself in any point of this model and see how things are coming together. Very powerful tool. It can help getting your signs in the right place. So coming up to a junction, for example, does signs block the view? I mean, that's not going to change your final stage audits from your road traffic, but you can see there the traffic counters inducting there, another one here. Many people don't know about the loop detectors and axle counters that are on roads. Landscape area, where we can put the unsuitable material. A lot of the material we had here was marginal. We had to use a lime modification, basically rotering lime into the soils, hydrating it and getting it to the optimum moisture content, which then allows the compaction of that material. Otherwise, that material would not be suitable to go in the embankments. So back to a live aerial shot from the drone. You can see the black there, that's actually planings, road planings that we're actually using as a lower sub-base type material. So that's minimizing materials going off site. You can see the suitable material there, and the white of the French drains, filter drain at the edge of the carriageway going round. Once we had this bridge in, this helped a great deal with getting access back and forward. This was a borrow pit to get some sand and gravels, and then there was this bridge here that we had an option to design. So this went for a Beebo Arch. Apparently it's the widest span one in the UK, because this is a floodplain area. The sections came in on their side on lorries, and the crane either side lifted the arch, rotated that into a vertical position, and then they went together in pairs. Where they then didn't meet at the top of the crown, temporary works is required with blocks and props to hold it in place, and then the strips at the back were filled with reinforcement, joining up the existing bars, and then concreted in place so the whole arch was one. We then swing round and start heading north again. Now, the reason I'm using this footage is, rather than the up-to-date one, you actually see more in it, rather than a finished road, which is in this location at the present moment, if any of you are driving up and down. But then on the right-hand side here is where we were into agricultural fields, and you can see as the hills appear, there's quite a volume of material to come out. So there's a new road for the part of dual carriageway there, and then this access road for farms running down the side like a parallel. Site compound here, and adjacent to it, Breedon's had a quarry. They produced the cement-bound material for the CBGM, surfacing and the concrete. So coating plant, you can see just sitting there, a concrete plant here, and a screening plant across out of the view on the left-hand side. Existing fields, so the new excavation came right up here, so cut-off drains, and you had batter drains where water would seep out. All that had to be controlled. The existing junction going into Bank Foot is going to be remodeled, so temporary and then a permanent around the back. And this junction becomes longer, so the vehicles are travelling at a faster speed on the new carriageway, so the merge and demerges are increased. Now, this can be seen on the next part, which is a sort of animated video, which can be produced beforehand. And the whole point of this is that even local people can see what we're intending to build. So when we're finished, it should look a bit like this, with the longer junctions. And here, so here we got the modelling here, then the building in 3D, and it can be moved back and forward to help design, resolve issues. Huge excavation here on the hillside, which then took us to Bank Foot. Now, the existing bridge, under bridge, was just so long, but we had to extend it because on the skew over 50 metres with quite extensive wing walls, whilst keeping this road open. Now, some of you came up to do a hackathon to say, how are we going to build this? So for those, I think with Ben, yourself, and a few others, so at this point, you can see actually ended up was the option. We actually ended up putting traffic lights on and then building both abutments simultaneously. I think one of the groups was designed it alternatively, and one group came up simultaneously. So using a formwork, this formwork is called Perry. The trio, modular panels, very quickly put together, standard from there. Meanwhile, the earthworks happening in the background offline. They're waiting for us to get the structures finished. But a lot of problems with water. So temporary suds ponds. We used added chemical flocculant from TATEC. This helped to clean the water before it was discharged. So the two abutments were in place there, and okay, so get that blackjacked and backfilled before we could put the beams on the top there. In this area here, you see the white appearing in the background there. This is a lime tanker, so in between the snow, applying the lime, modifying the soils, and bringing them up to a structural embankment. And if you blink, you miss a lot of things at the speed of this. So that was COVID back in March. Fantastic weather, not permitted really to do anything. Then we got back and started. So then getting the fill in between the road here, because new road to the, and then the two slip roads. So the new slip road comes down and round, traffic going in or traffic coming up and going back out. So no cutting across the carriageway. Quite a large extensive suds pond there. Huge catchment areas when you're constructing roads, especially with the downhill. Now, you'll see the existing, I'm going to just stop this here. So the existing fields are here, the existing road there. So the slope has had to move all the way back and up to here. Now, if that was continued all the way through, the local farm there would be in thin air. The farm was staying. The design was a piled wall here, but we've put, and this is one of the things when design and construct, you have opportunities to come up with other design solutions. And we went for a reinforced earth wall here, digging down and then putting effectively anchor pins into the ground, benching it down as we go, and it's then soiled off. Now, actually, interesting one there, you'll see the blow knocks and they're actually surfacing between the two carriageways. That's because when the traffic comes down there, we're just building in a temporary crossover. So before we really started, and this is putting out your fence lines, and then we erected a timber acoustic fence to cut down noise. Dig down a bench, and then the rock anchors, in effect, are soil nailing, drilled very quietly into the embankment. You can maybe just see the one or two the bars still sticking out. So this went down a level. You rolled that down, and then you basically bench this so you can have access for the rig, and then topsoiling over, and effectively that ends up being a grass slope. Carry on heading northwards there. The new carriageway surfaced because the existing ones on the left-hand side. At the present moment, the traffic's on this side and ripping up and redoing this one. Another bridge here, mainly for farm traffic, called Tranny. Very similar design to Palandi, the first one we saw. So the formwork that we've used, you can see very similar design. Only difference will be heights of columns. Sheet piles on this side because there's cables up the side there, telecom, fiber optic. And then when it's ready to go, again, we had to shut the road, lift the beams in, and then you can see the cantilever formwork, paraslims in. The white is the precast, the pre-GRP panels, and then the reinforcement in. So you got diaphragm, deck, and then it's casting the decks. Once the deck's up to strength, and then casting the diaphragms, which take it all together. Once the deck's done, it's then casting the copes. Gives a lot of strength to the deck. We can then backfill and do the extension wing walls either side. Coming up. So the existing path for the farmer was on the side there, and then now it's just going to be straight over and no access onto or off the A9. Heading further north in the last section, a lot of trees came out here. The trees were used to sawmill, and what wasn't was chipped, and that went to a biomass station in Bergordon. 4 laybys are going to be on, 2 at the south, 2 at the north here. BT mast was there, took a year to move it to there. For those who drive up, you'll see a fantastic dry stone wall that's been built along that section there. At the top section here, another bridge, and this is for the estate, and 1 or 2 people that live along here at Gillywood. Now, before we were here, this was one of the highest points of the section of road here. A lot of peatland trees, not a lot to grow, as you can see in there. So this was the existing junction before we started. Culverts existed. These had to be extended. Earthworks and construct the bridge there. We put in temporary turning points. This allowed us to, instead of going up and turning at the top and coming all the way back down, they could actually turn from there, cut down the amount of vehicle movements, and then eventually tying back into the existing bridge, the existing carriageway at the north end there. So that's a dual carriageway that goes down to Burnham, and then there'll be a section to be dualed at Burnham, but that'll be a different contract. So that was a quick fly through of 15 minutes, which has taken about 18 months to put together there. Let's see if I can come back to where we are on this. So do I say stop sharing or something? Let's have a look. Stop screen. Right, how's that? So I don't know, Ben, you're still on the call here?
Yep. Ben, is your...
Yep, hello.
Am I going?
Yep, I've got you.
There's a bit of a
Awesome.
delay there.
Well, sorry, Ben, I'll let you go.
On you go, Stefan.
Well, first of all, I'd like to say thank you very much, Ken, for your time there. Obviously the video there is very broad. I think you've put it very nice, very neat for the time being. As you said, 18 months. It's a lot for just a short video. But you can clearly see that there's many career types that we're using in this project. You can see, like, obviously surveying, structural, yourself as a project manager. There's many careers.
Yeah, there's a whole range. If you think, and I describe it as cogs of a clock in old terms, or you need a whole range of types of people, from office managers. You need admin assistants, QA. We have our own lab on site, so there's lab technicians and lab managers, setting out engineers, section engineers. You've got earthworks, structures, drainage. You've got different disciplines then going on to roadworks. So there's quite a varied, and a lot of them all come from universities with degrees. Some actually we start with day release. And they'll do a day a week, and we've got a couple of those as well. So it's quite a mix and match.
Awesome. Yeah, it was just
sorry, just to add on to that point there. It was another interesting talk for me as well, where I've been working on the A19 Testos down south, at East Bolton near Newcastle with Costain. Worked with them last year, and that was another massive highways project with Highways England, and we were doing a flyover bridge and stuff. So it's great to see another example of another major highways project.
Oh, what I missed out from my list was the A189, which is just up from your A19. So we did the last section of the Spine Road back in 1998. That was first order. Yeah.
Right. Yeah.
I'd say as well. Sorry, Ben, on you go.
Yeah, well, I'm just going to highlight the effect of the 3D modelling that you showed. Yeah. Just the fly through is really impressive, and it's great to get that sort of imagery of what
they're very powerful. Yeah.
Yeah.
I was just going to say that it's quite effective as well for people like myself and Ben and Stefan who have been up to Bankfoot in past years. I think I've been up twice. I think you've been up as well twice, Ben, and worked on bits of Bankfoot, and then obviously that video is updated, so you can just see what's actually happened in the time since when we've been there working on it.
Since we were last there.
I
There's still a lot going on.
I think some great advice for everyone is to, like, what was always at the pandemic's always try and get those site visits. Try and get into that mindset of being an engineer. It's crucial. There's maybe times where you're maybe not slipping up on studies, but maybe you just feel a little, but getting on site gives you that encouragement, gives you that motivation, and it's a good environment to have.
Yeah, and it's something again that you can highlight on your CV. I mean, I'm now applying for jobs as a graduate or approaching graduate engineer, and I've even got the hackathon that I done with Balfour Beatty highlighted on my CV, and it's another.
We were kind of hard on you that day. I must admit, it was quite a challenge. I don't know how drained you were, but I certainly was. And I've been doing this a number of years, but these hackathons were kind of new. We thought, let's take a group of students of different years, put them into a room, give them a problem, and let's see what we can come up with. But we're going to have to assist, and it's like one of these television competitions that you enter. You know, it's full on. But I think the energy that comes out of it and some of the ideas, you know, it might be something that we haven't thought of before, and it's a two-way thing. So it was great to have you guys up for the Bridge Hackathon, and then we thought, do we do one for that junction? And I thought they went very well, and many thanks for coming up and participating, guys.
Yeah, no worries. I mean, again, it was a great experience, and as Stefan's saying, it's something that everyone should jump on if they manage to get the opportunity, and they manage to get this sort of experience and something that they can then add on to their CVs, and it's additional experience that then sets you aside from everyone else is leaving the university with degrees. We've all got the same degrees. It's then this additional experience that you're showing on the CV that sets you aside from everyone else in these interviews that you end up going into for the rest of your career. I believe we do have some prepared questions that came in. I'll hand yourself over to Paul, who will take us from there.
So I don't know if you can see these, Ken, but I'm just going to read them out. There's the first one come up on the screen there. Sorry if I butcher your name. I've got Daoud Shafi asking.
Yeah, he was a student I had a couple of years ago.
Oh, there you go.
Nice.
He's asking, IIRC, did you mention before that there was a concrete layer beneath the surface or binder course? Can't remember which. Why the use of concrete?
Good question.
And he went on to add.
Design and construct, you are given options for your pavement construction. And depending what local materials are available, where quarries are, it's then, because you're in competition with other contractors to build this, you're trying to find the most economic form of doing that. And transportation materials can be quite a cost. And so this is why I suppose the most economic solution that came up was a lean mix concrete, in effect, as the layer between the sub-base and flexible pavement on the top. There's a requirement for X number of axles per year on the design. So hopefully that answers your question there.
He just added on the end there as well. Was there just over the bridge structure or throughout?
Was there just total of what, 5 bridges was there? So there's like one interchange bridge and 1, 2, 3 farm bridges going across, and then the bridge going underneath.
Thank you very much. He put thanks in the comments, so I think that answers the question.
Have I ever lost motivation? What's that? The Monday morning feeling for some people, is it? Motivation is one, I would say, one of the biggest things. If you can motivate everybody, it's great. And we always come up against problems, but that's, as engineers, that's what we have to do to try and solve them. yes, once in a while you lose motivation, and then what you need to do is step back and see the whole picture and say, right, this might be a problem here. Okay, if we can't solve this, who's been here before? How do we resolve this? Have a discussion, come up with a plan, execute the plan, and then you're back on the rails. There are a few contracts on the go at the present moment in Edinburgh, just with Balfour Beatty. So we have North Bridge, which is well underway, EFI, which is up near the new hospital, Edinburgh Infirmary. So the old hospital's getting refurbished from there, and then across a lot of France, there's another building there. So there are works going on at the moment. Whether you're looking for a full-time job or whether you're second or third year looking for a summer placement, I suppose just drop me an email and I can send it on, and we can take it from there. But always keen to see if somebody wants, especially second or third year, because you're a good opportunity to get a summer placement from there.
Yeah, and I can add on to that again, like stressing the point about these summer placements is really, I've been fortunate enough from second year, I got a summer placement each summer, and from there, the contacts you make, the networking, just everything about it is how you get further into the process. You end up getting to a point where you may have done your summer placement, and then it comes to your graduation and you've already been offered your graduate job from that company, depending on whether you've shown, obviously, qualities that they've been looking for. But yeah, again, summer placements are definitely a way forward.
There's another question from a Facebook comment there that Rory's put up.
Yeah, just something on my screen there. Just has BIM been implemented in the design and construction of the E9? So has it been? Yeah, very much so. And not everybody's up to speed with BIM. Some people actually prefer to use the old systems and from there. But I think what we need to have is an integration between the two. Have systems that do work already, but new technology that we can use and make things more efficient, because that's how the industry is going to have to go forward from there.
If we get any more questions?
Yep. Daoud Shafi's added there.
What's the best advice you could give a student watching this today?
There's another one.
Get some site experience and decide what you want to do. Find out if you prefer contracting or design, and go and get some experience. And go and find out sometimes, if you can, both worlds. Learn about both, because each will think the other one's better than the other one. But you then learn how you need to work together as a team, and where strengths are, and that's what teamwork is, knowing where the strength is. And as we touched on earlier, if you're going for interviews, are you literally just looking through the yellow pages and go, there's a number of companies I can apply to, or are you actually targeting companies because that's what interests you? You know, if you're going to go to work, what can the company give you, but what can you take to the company? What are you offering? What are your skills? You know, was it the fact that you went on a hackathon and you loved the challenge of the grey cells fizzling away trying to come up with solutions? Or was it the fact that the 3D modeling is what excites you? So find out what, one, you're good at, and two, you enjoy doing, because there's no point in going and doing something you don't enjoy. The secret to a job, as I would describe, is find something you enjoy doing, and then somebody pays you on top, and that's the bonus.
Yeah. Have we got any more questions in there?
Yep, there's a couple more just coming up.
Nice.
How long's left on the programme for the A9? They're hoping to be open late summer. I've picked up another contract at the moment, so I did a little bit of that before Christmas, and I'm starting this next contract afresh in just over 4 weeks' time, and that's the Funicular Railway in the Kame Gorms. So we've won the contract there to stiffen the structure, put in additional props and replace all the bearings. So for the first time, I'll be using helicopters and all sorts of lovely, expensive things like that. So a completely different logistical challenge. As I said, not all the problems are the same. We just have to adapt to them.
That definitely does sound like an exciting job, that Funicular Railway. I'd be interested in that one anyway.
Well, let me just give you a very short video.
In for a treat here.
Give us a shout when this comes on your screen.
We got it there, yep.
Yep, that's it.
Okay, the start of this is at 2,000 feet. It goes all the way up to the top, 3,600 feet above sea level. 94 piers, which support the structure, and there is a rotation of the piers at the present moment. So we've got to put in basically a prop, new concrete base, and then prop, and then change the bearings, and then there's some additional bolting and effectively stiffening. That's the short version. Biggest challenge here, you're in a national park, existing environment's got to be maintained, and you can't just go about it in a normal way. So some of the piers are shorter, some of them are a lot longer, and very much different. So so that's a sort of taster. And let's come back to stop sharing. Yeah, so yep. That's maybe one for another day.
All right. So Paul, if we get any more questions in there?
There's one from me there. Yep.
Yep.
Interesting question, that one. So okay, so let's look at your standard structure. So you've got your abutment base, your abutment itself, bridge deck, and then your bridge deck is either precast beams, because you don't want to be pouring concrete, live concrete on temporary works above a river where possible. And so it's one of the previous bridges, we'd have a similar design for that one there. An arch, you've basically got a concrete base strip along the bottom, and the two units come together. There's a lot less construction in the arch. It's a bit more in design, but it can be a very simpler solution.
Does
but it has a different clearance envelope underneath. You haven't got a rectangular area. You've got an arch, which suits a river. And one of the questions that SEPA asked was, by changing it to an arch, would that affect the hydraulic flow of the river, especially with flooding? And the answer to that was no. It's not the first time Balfour Beatty we've used an arch. For those of you who've driven the M77 just south of Lockerbie and before Ecclefechan, I think the precast arch we put in there at the time was something like 250 to 300 meters long, which actually encompassed the West Coast main line. So not only was it 2 tracks, but also the electrification. Cost-wise, as somebody mentioned there, it can be cheaper because you're spending less time on site doing it, and it can be less concrete as well. Basically, what you need to do is do a cost exercise between the two, including your transportation and your cranes.
I see. I think we've got one more question.
Okay, we have our own one that we use in-house. We have to record our sustainable facts, whether it's just in usage, water, diesel, from there. There's also the embodied carbon. So one thing about roads is it's very difficult to get away when you're using concrete, the amount of carbon that's used. So one of the things you can actually do is use a blended cement rather than a full OPC. We've also got in the CSR reports we've done is how much money we have spent and how much money that has been put into the community. And these can have great figures that we can use from a sustainability point, which is not necessarily just environment. Okay.
Yeah, and that's a question from one of the students that is taking part in Crusoe's CC's module, the Integrated Design and Engineering module, where we're designing music arenas. So I believe we do have a few students on there at the moment.
Oh, I've lost the call. That's what's happened. Right.
That will have questions. Back. Sorry, we're technical issue. I'm phoning Ken back.
Got engaged now. Okay. So maybe he's trying to phone me back. So I've only got audio going one way, guys. You can hear me, but
yep.
What we were doing was doing this through my phone to Ben. I'll try phoning Ben again.
So we've got some students on there that are currently going through the project with the music arena, and
okay, it's ringing, Ben.
We've all got different roles. We've got project managers, structural engineers, geotechnical engineers, and of course Ken Brown's had a vast experience within the industry, and he's obviously covered many of these roles and currently a project manager at Balfour Beatty. So again, any other questions that anyone's got for this project that we're currently going through, fire them in. Additionally, this is recorded and it will be uploaded on Crusoe's middle page as well.
On Facebook at the minute.
Yeah, I've got you now. Thanks.
There's no more questions on Facebook at the minute.
When should we just call it a halt then? I'm pretty sure Ken wouldn't mind the emails or.
Yeah.
Would you?
To touch on that, as Ken was suggesting, anyone that's interested in summer placements, whether you're in first, second, third year, definitely couldn't emphasize it enough to try and get involved with another company within the industry during your studies. You can either also contact Ken directly, or you can contact myself or the ENBE team, and then we can forward it on to Ken as well.
There's also the Balfour Beatty webpage if you want to look at that.
Yep. Again, Balfour Beatty webpage, and you'll have there'll be links to their sort of career tab that you can go on.
It's emerging talent team. Yeah.
Yep. Perfect.
I'm pretty sure he's quite easy to find on LinkedIn as well. So you've also got that media page.
Yep. No, perfect. So again, just thank you very much to Ken Brown for his time. It's been another great opportunity for everyone involved, getting an insight not only to the A9 dueling, but again a quick snapshot of the exciting project that's coming up, the Funicular Railway. So again, from myself, thanks very much for your time and your support of this event. I believe this may be the last event for this year. We're hoping that there's been continued recognition from Napier. It's been something I've been pushing since I've joined the society, and we've now started sort of getting in higher up in Napier, and we've got contacts that are now wanting to develop this even further, because now that we've entered this sort of COVID stage and we're in lockdown, the virtual events and digitalisation within the industry is massive now, and it's going to be the way forward. Like this call right now.
Yeah, I mean this is only an hour of my time, but if I was coming in, it's half a day.
Yeah, exactly. So you're and we're killing two birds with one stone. We're recording it and it's getting used again. So we've again, it's got massive advantages. We do hope I will be doing the handover soon. I'll be graduating this year. Potentially going consultancy, project management, or I'll be going construction with Costain as a site engineer. We've got the new team that we're coming up. Stefan, I believe Paul as well, maybe staying on during his masters in 5th year. We do hope to continue these events and continue the support. Again, with the importance of the summer placements and getting contacts and networking, that's one of the main reasons why I was able to start this event in the first place, because it started off with the companies I done summer placements with. And again, just people I've met through meetings and various things with the ICE as well. So yeah, if any, Stefan, Paul, if you get anything else to say, we're nicely wrapping up to 51 minutes there, which we're on.
We're on time for a change. Yeah, I think what you've evaluated there is perfect, Ben. Just for anyone that is interested in society that can that you feel that you can contribute, I'm pretty sure if you can give us an email, and we can try and work you from there. We like new faces, new bodies, and obviously it helps towards your future. But yeah, just another big thank you to Ken.
No problem, guys. No problem.
Another big thank you to Fraser Reynolds in the background, and Annie Fennell, who's helping on the Facebook side. But yeah, if Paul's got any more questions, and
yep, thank you very much, Ken. I appreciate your time coming on. For anybody that's watching and maybe wants to hear more from Ken in the future or get involved in any site visits or anything, we'll be sure to get in touch with him again through the society. Hopefully sometime in the future we can go back outside again and do a bit more of that.
And you'll be surprised on the internet, guys, if you type in Ken Brown and Balfour Beatty, what's there? I certainly was.
Right, no problem.
I hope it's all good stuff, Ken.
The powers of the internet.
Yeah, so it's really surprising what's there.
Yeah.
Okay, I think we'll probably just end it from there.
Yeah, that'll be us.
Yep. So from me, Ben, Paul, and our special guest Ken Brown, we just like to say thank you for joining and take care.
Thank you.
Thank you.